So aside from using a vector to move a shape, another common vector type question that comes up is, well, we've got a before and we've got an after, and we ask, well, what was the vector that got us there, right? Now, we've already kind of done this before when we were testing out whether certain movements represented a vector or not. And all we have to do is do that end minus start equals change. So here we have that some vector moved point B down to point B double prime, to 2 tick marks, double prime, just to differentiate it from the regular B prime. And here you have a table. This vector is called HK, so H spaces left or right, K spaces up or down, and it moved the point 1, 9 to the point -5, -3. So we're going to check here to figure out our change in x was end minus start, so -5 minus 1 equals -6. And our change in y is -3 minus 9. End minus start makes -12. So our vector is -6, -12, or 6 spaces to the left and 12 spaces down. We just check that here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that works. So we'll do the same thing to the other 2 coordinates. So let's see, -3 minus 6 is -9. And 6 minus 12 is -6. 6 minus 12 is -6. Yeah. And then for C, 3 minus 6 is -9, and 6, I made a mistake there. That's +3 minus 6, that's -3. There we go. -6. Now, something you can do here is if you know where the one corner is, and a translation produces a figure that's congruent to the original, so it's the same shape. So all the relationships between the side lengths and all that stay the same. Angles, everything stays the same. So I can actually look here from B to C is down 3 and forward 2. So from B prime to C prime will be down 3 and forward 2 as well, or C double prime. And then from B to A is 1, 2, 3 down, and forward 1, 2, 3, 4, back 4, I guess, sorry. And so it'll be the same for B prime to A prime, 1, 2, 3, 1, 2, 3, 4, A double prime. And if we check here, see, A double prime is supposed to be -9, -6, so check those coordinates, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6. So sure enough, -9, -6. And C prime was supposed to be -3, -6. We'll check. C double prime, I keep saying that wrong. 1, 2, 3, 1, 2, 3, 4, 5, 6. So sure enough, -3, -6. So again, if you're asked to, if you're given the beginning coordinates and the ending coordinates, and you're asked, well, what's the vector that moved it there? It's always end minus start equals change. End minus start will give you the change in x. End minus start gives you the change in y. And from that, you'll have your vector, and then you could apply your vector to other things that may be moved by that same vector. Also remember that when you move a shape, all the relationships between the parts of that shape stay the same. So that translation doesn't make the sides longer or shorter or anything. So once you have one point or one vertex, you can then kind of just figure out where all the others are based on how they are arranged in the original shape. So a couple different ways. It's also good, by the way, to use that as a double check for yourself. So if you've performed the translation and you look down here and you're like, my second shape looks a little off, right? It doesn't look quite like the original. You can check. Do the distances between each sides, do they match? So A, B should be the same length as A double prime, B double prime, or over here A prime, B prime, and so on. Right? And if they don't, you can use that to kind of figure out maybe where you've made a mistake.